Hi kids, in a previous video we have solved till sum number 11 of exercise 15.1 from class 10 circles based on angle properties of circle. You can click on the I button and get the link of the previous video. Now look at sum number 12. In the figure AB and CD are equal chords. AD intersects BC at E. Prove that AE is equal to CE, BE equals to DE. Pretty simple. If you can prove that these two triangles are congruent, our work is done. Now look carefully. First of all, this angle and this angle, if you look, BAD, angle BAD is equal to BCD, isn't it? Same segment, BD. Look over here. Okay. Similarly, if you look, actually now, angle BAD, can I write BAE? Same thing, BAE. And angle BCD, can I write DCE? DCE, same thing, isn't it? Now look carefully. This angle and this angle, angle ABC, angle ABC is equal to ADC, same segment, which means because AC is the segment C, so angle ABC will be equal to ADC. Now look carefully. Angle ABC, can I write angle ABE? Yeah. And angle ADC, can I write CDE? Yeah, I can write CDE. Okay. Now look carefully. In triangle ABE, and triangle CDE, if you look carefully, AB is equal to CD. That's given to us. Angle BAE is equal to DCE. DCE proved. We have done that earlier, isn't it? This one. And one more thing, angle ABE is equal to angle CDE. CDE proved earlier. Which means if you look carefully, these two triangles are congruent. Angle side angle. Triangle ABE is congruent to triangle CDE, angle side angle. And if they are congruent, we know that corresponding part are equal, which means we can say that AE is equal to CE and BE will be equal to DE, CPCT. Then just prove that these two triangles are congruent and the work is done. Clear? Now let us look at the next sum. Look at this sum. Very beautiful. If circles are drawn taking two sides of a triangle as diameter, prove that the other point of intersection of these circles lie on the third side. Which means, suppose I take a triangle ABC. Now with AB as the diameter, suppose I draw a circle with AB as a diameter, draw a circle. Okay, suppose it intersect BC at D. We need to prove that if we draw a circle with AC as the diameter, then it should pass through C. We need to draw a circle with AC as the diameter and it should pass through D. Clear? Question is clear? Very easy. Look over here. What I'll do for the first circle with AB as the diameter, forget about the second circle. I'll join AD. Okay, now AB is the diameter. So angle ADB is equal to what? 90 degree. Angle at semicircle, isn't it? So this is 90. Now look carefully. Angle ADC plus angle ADB will be 180. That's linear pair if I'm not wrong, which means angle ADC will be 180 minus 90. That's 90. Am I clear or not? Now just talk about ADC. Just talk about this triangle ADC. Now this is 90. Now we know that in a right angle triangle, if you take hypotenuse as the diameter and draw a circle, then it will pass through D, the other vertex, because if AC is the diameter, then ADC, since it is 90 degrees, this becomes angle at a semicircle, which means this portion will be a semicircle, isn't it? So ADC is equal to 90 degree, which means if we draw a circle with AC as diameter, it will pass through D, isn't it? So D will be the common point of intersection of the two circles on the third side, which is what we were supposed to prove. See, angle in a semicircle is 90. So now if you draw a circle with this AC as a diameter, the circle which you will get will pass through D. No doubt in that. Is it clear? Pretty easy, okay? Now let us look at the next sum. Now look at 14 part A. Pretty easy. In the figure, AB is the diameter of the circle with O as a center. AC and BG are perpendiculars on the line PQ. BG meets the circle at E. Prove that AC is equal to ED. Pretty easy. Just look over here. What I'll do, I'll just join AE. Now, when you join AE, don't you think that this angle AEB is equal to 90 degree? Why? Angle at semicircle. Angle at semicircle. So, this angle is 90 degree, which simply means angle DEA, this angle DEA will be 180 minus 90, that's linear pair, will be equal to 90, which means in the quadrilateral AEDC, see, angle C equals to 90 degree, angle D equals to 90 degree, angle E equals to 90 degree. Three angles are 90 degree, which means of course the fourth angle will be 90 degree, which means it transforms AEDC is a rectangle. And if it's a rectangle, all the four angles are 90 degree, which means it's a rectangle. If it's a rectangle, the opposite sides are definitely equal. No doubt in that. Just we needed to join AE and prove that this figure AEDC is a rectangle. Once that is done, the opposite sides are equal. That's proved. Okay. Now let us look at the next sum. Now look at 14 part B. In this figure, O is the center of the circle. Chord CD is parallel to AB. Angle ABC is 25. They have asked us to calculate CED. This angle. Look what I'll do. First I'll join OC and OD. Join OC and OD. Now look carefully. Angle AOC will be twice angle ABC. Angle at the center is twice the angle at circumference. See, the segment is same. Angle at center is twice angle at circumference, which means angle AOC is 2 into 25, that's 50 degree. So this is 50. Okay. Now look carefully. If this is 50, this has to be 50. Angle OCD, because OCD is equal to AOC. That's alternate angle, which means angle OCD is 50 degree. Isn't it? Now look at triangle OCD. Triangle OCD. OC and OD are equal. Isn't it? Which means angle C and angle D will be equal. Angle OCD is equal to angle ODC will be equal to 50 degree, because OC and OD are equal, so it's an isosceles triangle, so base angle will be equal. So this is 50. Now if this is 50, this has to be 50. Alternate angle, isn't it? Angle DOB is equal to ODC is equal to 50. That's alternate angle. Now once you got these two angles, we can easily get this angle. All these three angles add to give 180. So COD, angle COD plus 50, that's equal to 180. Straight line, isn't it? Which means angle COD is 80 degree. Now look carefully. Angle COD is nothing but twice of CED. Angle at the center is double the angle at circumference. So angle COD is twice angle CED. Angle at the center is twice the angle at circumference. See, CD, the arc is same. Now, angle COD is 80 equals to twice angle CED, which means CED will be 40 degree. Look carefully. You need to construct, you need to join OC and OD. Then use the theorem, you'll get the answer. And we've used the property of isosceles triangle also, even the parallel line property. Clear? Now let us look at the next sum. Now look at number 15. Pretty easy. In the figure, O is the center of a given circle and OABC is a parallelogram. BC produced to meet the circle at D. Prove that angle ABC is twice of OAD, which means we need to join AD. OAD, which means this angle is ABC. This angle is twice of OAD. Now look carefully. First thing, look at these two angles. Angle AOC is twice angle ADC, isn't it? Because the segment is AC. Angle at the center, is twice angle at circumference, isn't it? We know this. Now look carefully. Angle ADC and angle OAD are same. How come? Alternate angle. Angle OAD is equal to angle ADC. That's alternate angle, which means in this AOC, instead of ADC, can I write twice of OAD? Yeah, definitely I can write. Okay, because OAD and ADC are same. Now look carefully. In this parallelogram, this angle and this angle are same. Opposite angles are equal. So instead of AOC, can I write ABC? ABC is equal to AOC, which simply means angle A. Instead of this, I'm writing ABC will be twice angle OAD. This is opposite angle of parallelogram. They are equal. See, just in 4 steps, the sum is done. You need to join AD, use the property. Pretty easy. Clear? Now let us look at the next. Now look at 16 part A. Pretty easy. In the figure, P is the point of intersection of the chord BC and AQ. such that AB and AP are same. Prove that CP and CQ are same. Just if we can prove that this triangle is an isosceles triangle, our work is done. Which means if we can prove that these two angles are equal, our work is done, isn't it? Now look carefully. In this triangle ABP, in triangle ABP, AB equals to AP, which simply means that angle ABP is equal to angle APB, suppose equal to X, let. So this angle is X and this is X. Now look carefully. Angle ABC, angle ABC is equal to AQC. This angle and this angle are equal. Same segment, C, AC. Same segment. So this angle we got as X. Now, if you look at angle QPC, this angle QPC, that will be equal to BPC, that is equal to X, vertically opposite angle, isn't it? Now look at triangle PQC, angle QPC is equal to angle PQC is equal to X. If these two angles are equal, the side opposite to these angles are equal, which means PC will be equal to QC, which is what? CP equals to CQ. Proved. Isn't it? Pretty simple. We just used one property, that was angle in the same segment are equal. Clear? Now let us look at the next sum. Now look at 16 part B. Very easy. In the figure, AB is equal to AC is equal to CD. Angle ADC is 38. Calculate ABC, which means this angle, and BEC, which means this angle. Now look, first of all, ACD, in triangle ACD, of course AC is equal to CD given, which means angle CAD will be equal to CDA, will be equal to 38 degree, isn't it? So if this is 38, this is 38, no doubt in that. Now look carefully. In the same triangle, this angle, exterior angle, equals to sum of opposite interior angle, which means ACB will be CAD plus CDA, which is 38 plus 38, which is how much? 76. So this is 76. Now look carefully. ABC is an isosceles triangle. In triangle ABC, AB equals to AC, which means these two angles will be same, which means angle ABC is equal to ACB is equal to 76 degree. Done. So this is 76. Now they have asked BEC. Look carefully. Can I get angle BAC in this triangle? Definitely. Angle BAC will be 180 minus 76 plus 76. Angle sum property. So that's 180 minus, this is 152, that's 28 degree, isn't it? Now look carefully. BAC, angle BAC will be equal to BEC. BEC will be equal to 28. Same segment. Just look at the diagram. BAC and BEC, they are in the same segment. So if this is 28, this has to be 28. Done. I think pretty easy, okay? Now let us look at the next sum. Now look at this sum, 17 part A. Very interesting. In the figure, CP bisects angle ACB. Prove that DP bisects angle ADB. Which means we need to prove that these two angles, angle ADP and PDB are same. Now first of all, let angle ACB is equal to twice X. Let. Okay. Then ACP, angle ACP will be equal to PCB. PCB will be equal to X degree each. So this is X and this is X. No doubt, because CP is the bisector. They have given that. Now look carefully. Angle ACB, angle ACB is equal to ADB. ADB, that is equal to 2x. Why? Look carefully. Same segment, isn't it? AB, AB, which means this entire angle is 2x. Now if you can prove that this and this are x degree each, our work is done. Then DP is the bisector of angle ADB. Look carefully. Angle ACP, angle ACP is equal to ADP. ADP is equal to x. Why? See, same segment, isn't it? So this is x. This entire was 2x. Therefore, angle PDB, angle PDB is equal to 2x minus x. That's x. Which means both the angles are equal. Which simply implies that angle ADP is equal to PDB, x degree each. Which means that DP bisects angle ADB. Done. Pretty easy. We just used one property, that's angle in the same segment are equal. Okay. Now let us look at the next sum. Now look at this sum, 17 part B. In the figure, BD bisects angle ABC, which means this angle and this angle will be same. Prove that AB by BD is equal to BE by BC. We know that's similarity sum. Look, first of all, what I'll do, I'll join DC. Join DC. Now look at triangle BAE. BAE and triangle BDC. BDC. Now before that, this angle and this angle are equal. Why? Same segment. See, BAC is equal to BDC. Same segment, isn't it? Just look carefully. The segment is same. Achha, BAC, can I write BAE? And BDC, can I write? Yeah, leave it like that only. Okay. So in triangle BAE and BDC, this angle and this angle are equal. BAE is equal to BDC. Just proved. Okay. And ABE is equal to DBC. DBC. Why? Because BD is the bisector. So in these two triangles, you know, BAE and BDC, two angles are equal, which means they are similar. So triangle BAE is similar to, now B corresponds to D, B corresponds to B, A corresponds to D, and E corresponds to C. They are similar. Look carefully, angle property. Now if they are similar, BA by BD will be AE by DC will be BE by BC, isn't it? Equate the first two, the first and the last one. BA by BD equals to BE by BC. Proof. We were supposed to prove this only. We used the property of angle in the same segment. Okay, and then it was similarity. So in this video, keep it till here. In the next video, we'll do the rest of the sum. Till then, take care.